As always, my name is Hendrik Makaneta, and I'm going to teach you mathematics, grade 7, today being the 7th of July. And of course, what is important is that please feel free at any time to ask a question if you have any, and allow me to indicate that that season for assessments has arrived. And so today I'll just be taking you through some of the work that we have already done. That will be revision work in the form of a lesson. So today's lesson is going to be based on common fractions, where we are going to add and subtract common fractions. And then hopefully tomorrow we can just multiply and divide fractions. So what is important is that, please note, it's important that we also participate in the chat or the group chat rather, as well as asking questions if you have any at any time. So today's lesson is going to be quite interesting in the sense that we will be looking at the various fractions. Right? I just want to introduce it as follows. You can only add or subtract fractions when denominators are the same. In other words, if you are adding or subtracting fractions, you first have to convert all the fractions just to make sure that your denominators are the same, because there will be instances where you have to add fractions which do not have the common denominator. So I just thought, let me do that as a starting point, just to redefine the fractions, and especially when it comes to addition and subtraction. So I'm not going to waste time. I'm just going to zoom directly into an example. If you look at this example 1 here, you can see that the lowest common denominator will be 10. As you can see here, we don't have the same denominators. The first fraction there, 3 over 5, the denominator is 5, and the numerator is 3. Remember that the numerator is the number that comes at the top of your fraction, and the denominator is at the bottom. So the second fraction, which is half, or 1 over 2 as some may call it, the denominator there is 2, and the numerator is 1. So you can really tell that these two fractions do not have the same denominator. One, the denominator is 5, and then the second one there, the denominator is 2. So there is a misconception which is sometimes made by the learners. I'm talking here about the mistake. Some of the learners make the following mistake. They will add 3 and 1 as the numerators to get 4, and thereafter they will add 5 and 2 to get 7, and then they will say that the answer is 4 over 7. Please note that that is false. If you are one of the learners who have been doing that up to so far, please note that that is wrong. You cannot add the numerators as well as add the denominators. The only time when you can add the numerators is if and only if the denominators are the same. And in such a case, you still add only the numerators. You don't add the denominators. You only add the numerators if the denominators are the same, and then you keep one of those denominators because it's a common denominator anyway. Now, if you can see here, as I've just indicated in the previous slide, that the most important thing for you to do is just to find the lowest common denominator. And the lowest common denominator is 10. Why do we say 10 is the lowest common denominator? 10 is the lowest common denominator because both a 5 and 2 can divide into 10 without a remainder. In other words, the 5 can go into 10 without a remainder. 2 can also go into 10 without a remainder. And in this case, we are taking the lowest common denominators. Please note that there can be other denominators, such as 20, for instance. 20 as well can be a denominator, but it can be, it's not the lowest. Remember, 5 can go into 20 without a remainder, and then 2 can also go into 20 without a remainder. So there are different denominators. There are many of those that you can list, but in this case, we take 10 because 10 is the lowest. After 10, there is no other denominator which will be common for 5 and 2. 9 is not a denominator. 8 is also not. 7 and so on and so forth. Even 5 is not a denominator because 2 cannot go into 5 without a remainder. Now, I've just worked it out for you, the example, just so that you can see how we have managed to solve this problem. In this case, excuse me. Right, in this case, what we are doing now is just to convert. We are now converting our fractions, and then we want, the reason for this is we want to have the same denominators in each fraction. Remember, we have to add, the most important thing here in this example is that we need to add 3 over 5 and 1 over 2. So we have a fraction here, addition of fractions, so we need to add 3 over 5 plus 1 over 2. Now, as I've already indicated, all that you need to do is just to convert this fraction. And remember, we have done fractions before. The reason why I'm bringing it up is because we are going to have the assessment somewhere next week, the 13th of July. You'll have an opportunity to be assessed. So hence, we have to go through this revision work. Now, how do we convert 3 over 5 as well as 1 over 2 and make it fractions in such a way that both of them have got the same denominator? So the first step that you do, you are going to multiply by 2. You can see the red numbers there. Because the LCD, we've already agreed that 10 is the lowest common denominator. Then all that you need to do in order to convert 5 to 10, it means you need to multiply the 5 by 2. So we have multiplied 5 by 2. You can see the red number there, 2. And then 5 times 2, we know it's going to give us 10. But you cannot just multiply the denominator and leave out the numerator. Whatever you do to the denominator should also be done to the numerator. The reason being, this will keep the value of our fraction as it is. It will not change the value of our fraction. So if you multiply 5 by 2, then you must also multiply 3 by 2, as you can see in the example. Then the plus, the half there, in order to make 2 and convert it to 10. If you want the denominator to be 10 there, it means you need to multiply 2 by 5, because 2 times 5 will give us 10. Remember once again that you don't only multiply the denominator, you also multiply the numerator by 5. So 3 times 2, as you can see, is 6, and then 5 times 2 is 10. So meaning that your fraction will now be 6 over 10. So these are also known as equivalent fractions. 6 over 10 is the same as 3 over 5. They are equivalent. And Huapili, I like your comment there, because you are saying that what you do to the top, do to the bottom. Great, I like that. What you do to the top, you do to the bottom. And what you do to the bottom, you also do to the top. Great. Now that we have got the new fractions now, which are also known as the equivalent fractions, 6 over 10. Now that we've multiplied everything there by 2. We've multiplied the numerator by 2. We've also multiplied the denominator by 2. And then the second one, which was half, it's now 5 over 10, as you can see. We have multiplied 1 by 5, which is the numerator, and then we've multiplied 2 by 5, which is the denominator. Now you can see at this point, the denominators are now the same. Now the denominators are the same. So now that the denominators are the same, then by all means, you can add your numerators. Nothing stops you now from adding the numerators now that the denominators are the same. So as I've said, if you have got the common denominator in the fractions, then you can simply add the numerators. What are the numerators? 6 and 5. Those are the numerators. So all that you need to do now is to say 6 plus 5 gives you 11. And 6 plus 5 is 11. And then this will be over 10. Remember, this is a common denominator. 10 is a common denominator, so you will have 10 in the denominator there. So 11 over 10 on its own is something called an improper fraction. So remember that an improper fraction, the numerator is bigger than the denominator. So if a fraction is improper or called an improper fraction, then we know that the numerator is bigger than the denominator. So if the numerator is bigger than the denominator, you have to now simplify that and turn it into a mixed number. So how do we turn that into a mixed number? You say 10 goes how many times into 11? It goes once, so you write 1 there, because 10 goes once into 11. So you write 1 and check, is there any remainder? Yes, there is a remainder. It goes into 10, but because we have 11 there, it means that the remainder is 1. So then you write 1 and then over 10. So the final answer will be 1. That's the whole number. 1 and then fraction 1 over 10. That will be the mixed number. I just want to emphasize it this morning because next week when you receive your assessments, this is part of the work that will be there on the assessments. And I just want to quickly help you and remind you of the importance of not adding the fractions in such a way that when you have a fraction like this, you say 3 plus 1. You know, there are learners who just think it's as easy as that. They will say 3 plus 1 is 4, those the numerators, and then say 5 plus 2 is 7, and say the answer is 4 over 7. That is wrong. If you do that, you are not going to get it right. So the most important thing is to first convert your fractions in such a way that you will have the lowest common denominator. I see that Huapele has made a comment there. It's asking, can you simplify? Yes, when it is an improper fraction, then you can simplify it and convert it to a mixed number. Unless the instruction says you can leave it as a common fraction, then that's okay. But if there's no instruction, then you have to now simplify your fraction. Right. And this was the first example, and I hope that it makes sense. If you have any question, please feel free at any time to ask. But I'm not going to leave it there. I'm just going to zoom directly now into the second example, example 2, and I hope that example 2 will surely, give you more insight. And I'm sure that at the end of the example 2 and example 3 in particular, you will understand the addition and subtraction of fractions much better than you did before. Right, the second example you can see again, we are subtracting a fraction from a fraction. So once again, what you need to do, you cannot just subtract the numerators and the denominators. And there are some learners who are quite, unwilling to walk an extra mile. What they do, the learner will simply subtract a numerator from the numerator and then a denominator from a denominator. That's not how it works. Once again, if you have a fraction of this nature, 3 over 4 minus 6 over 7. 3 over 4 minus 6 over 7, you can tell without any waste of time that the denominators are not the same. So the denominators are not the same. What do you do now? You need to look for the lowest common denominator. In other words, you need to look for a denominator which is divisible by 4, also divisible by 7. Yes, it's called the LCD. The LCD, thank you very much, Wapele. It's also known as the LCD. It's just that I'm just mentioning it in full. The LCD stands for the lowest common denominator. That's what it stands for, right? What is the LCD for 4 and 7, those two denominators there? So you can tell without any doubt. Some people find the LCD by multiplying the denominators, as a product of the two denominators. For instance, if you multiply 4 by 7, you will get 28. And 28 will be your lowest common denominator. But it's not always the case that when you multiply your denominators, you will find the lowest common denominator. In certain instances, you will not find the lowest common denominator. You will still find a common denominator if you multiply the two denominators, but it may not always be the lowest common denominator. And I hope as we proceed with our lesson, we'll hopefully find other examples whereby if you multiply the denominators, you don't always get the lowest common denominator, but you do get a common denominator. If you multiply the two denominators, you will certainly get a common denominator, although it may not always be the lowest common denominator. So, by the way, you are not prohibited from multiplying the two denominators. You can use any denominator as long as it's a common denominator. At the end of the day, you'll have to simplify your answer. Now, in this case, 28 is the lowest common denominator, it's the LCD. So now that we found, how do we know 28 is the LCD? Because we know that 4 can go into 28 without a remainder. And in the same note, 7 can also go into 28 without a remainder. So 28 is divisible by 4. It's equally divisible by 7. So there's no remainder there, right? So the first step, you have to now multiply out your fraction in order to find the lowest common denominator. So you can see that the first fraction here, we had 3 over 4, or 3/4 there. Now, you have to, now that we have identified that our lowest common denominator is 28, you simply multiply 4 by 7. Whatever you do to the bottom, you also do to the top, as Huapel has said earlier. Now you multiply 3 by 7, and if you multiply 3 by 7, you'll get 21, and 4 times 7 is 28. That is why you now have 21 over 28. And then the second one, if you multiply 6 by 4, you will get 24. And then if you multiply 7 by 4, you get 28. And therefore, you now have a fraction here with another fraction with the same denominator. So if the denominators are the same, so you can simply now subtract the numerators. So in other words, 21 minus 24 will give you -3. Remember, if you subtract a bigger number from a smaller number, you are certainly going to get a negative result, because under normal circumstances, you cannot subtract a bigger number from a smaller number. So hence the negative sign. So this actually tells you that 24 is bigger than 21. So hence you need to subtract 3 from 24 in order to have the same balance. So 21 minus 24 is -3. And then the denominator is the same, which is now 28. So the denominator is 28. And I hope that the lesson has given you some understanding in as far as addition and subtraction of fractions. Now, the next example is a bit different, although we are also adding fractions. You can tell that we are now adding a whole number and a fraction. And our whole number in this case is 3, and then plus 5/4. So 3 is a whole number, 5/4 is a fraction. It's an improper fraction. How do you add the two? There are two ways. I'll give you two methods to solve this. And at the end of the method, the two methods, I'm sure you can decide which method is better for you. I'm just gonna demonstrate that 3 as a whole number can be converted into a fraction. It's very important that when you add a fraction and a whole number, you can turn your whole number into a fraction, so that at least you are working with the same fractions. It's easier if it's like that. For instance, we know that the whole number 3 is the same as 3/1. You will see that that is the starting point here. We had 3, which is a whole number, plus 5/4. And then I'm now converting the 3 into a fraction. Any whole number can become a fraction because you simply divide that by 1. So meaning that you now have a fraction which is 3/1. You can see the 1 there in red, 3/1. The 1 in red is now a denominator. So we have given 3 a denominator, because in any case, 3 divided by 1 is 3. So the value of the whole number there hasn't changed. It is not changed by 1, so it is still the same value. So we now have a fraction. We have now converted 3 into a fraction. And the fraction is as follows now: 3/1 plus 5/4. So how do you now add the two fractions together? Remember that the denominators are again not the same. One has a denominator which is 1, that is one fraction. The other fraction, the denominator is 4. So as I've shown you in the previous two examples, you now have to find the lowest common denominator. And in this case, the lowest common denominator for 1 and 4 will obviously be 4. It will be 4. Because 1 can go into 4 without a remainder, and then 4 can also go into 4 without a remainder. So in other words, you will now multiply the denominator there, which is 1, you multiply that by 4. And then whatever you do to the bottom, you also do to the top. Then you also multiply 3 by 4, so that the denominator can be 4. So I have not touched, if you can check, I've not touched the second fraction. And the reason is already we have 4 there as the denominator. So there's no need to multiply it by 1. I mean, you can if you want. If you want to, you can say 4 times 1, that's 4. And then 5 times 1 also gives you 5. So it will not change. That fraction remains the same. And of course, at this point, we are now multiplying 3 by 4 to get 12. That is our numerator. And 1 times 4 is 4. That is our denominator. Plus, and then 5 over 4. That is our fraction there. So now we have got 2 fractions. We are adding 2 fractions with the same denominator. And the denominator in this case is 4. Now that we have the denominator, all that you need to do is just to add the numerators. So 5, in fact, 12 plus 5 will give you 17. And the denominator, which is common, is 4. So our answer is 17 over 4. That is our answer there. But you can see that this answer is an improper fraction. So all that you need to do now, you can convert it to a mixed number by checking 4 goes how many times into 17. And you'll see that it goes 4 times because it goes into 16. So the remainder will be 1. So now it means the mixed number will be whole number 4 and then 1 over 4 or a quarter there. So it's 4 and a quarter. That will be the final answer of adding 3 and 5 over 4. I hope that you have seen the manner in which we have solved this addition as well as subtraction of common fractions. Now, this is one method of doing the example 3. The other alternative is you might as well, if you want, you can just convert your improper fraction there, 5 over 4, you can convert that into a mixed number. So that once you have a mixed number and a number, then you can add them together because they are both numbers. I know that some people normally call a mixed number. They want to call it a mixed fraction. It's not a mixed fraction, it's a mixed number. That is why you have a whole number there. It's no longer a fraction, it's now a mixed number. All right, so 5 over 4, you can be turned into a mixed number. How do you turn it? Who can tell me how are you going to turn 5 over 4 into a mixed number? Obviously, you will say 4 goes how many times into 5? It goes once. Is there a remainder? Yes, the remainder is 1, and then the denominator is 4. So it means the answer here for 5 over 4 is 1, whole number 1, and then 1 over 4. 1 and a quarter, simply put. If you divide 5 by 4, you get 1 and a quarter. So 1 and the whole number 1 and then 1 over 4. That's your quarter there. So now it's easier for you to add the 2 now that you are working with numbers. 3 is a number, 1 and 1 over 4 is also a number, but that is a mixed number. So you add 1, in fact you add 3 and you add the whole number 1, you'll get 4. So it means you'll get 4 and then plus the quarter there, it will be 4 and a quarter. So that's how you do it. That's the second method. So I hope that you decide which method works best for you in this case so that we can just proceed. Now that I've done the 3 examples, I'm going to now give you an opportunity to work out the following activities, which are additions, or rather we are adding common fractions. And you can see that we also add the mixed numbers. And of course, the last one as well has got a mixed number and a fraction. So what you need to do, let me give you a hint. What you need to do in this case is just to make sure that you convert your mixed numbers into fractions, those improper fractions. Then it will be easier for you to add the two. I think that's a method that I encourage. But alternatively, if you want, you can still add your whole numbers and thereafter add the fractions. That is also allowed. So there are many ways to solve fractions in mathematics. Can I give you about 30 minutes or so? Just, I hope that you have a pen and a paper with you just to calculate the three expressions there, the three fractions. I want you to add them, and then thereafter we'll do a subtraction of fractions. You'll get an opportunity to also subtract. So if you have a pen and a paper, please work it out, and then feel free at any time to raise your hand, and then we can talk. I see, I forgot the name. Is it, the number is Mian. Can you just remind me what's your name again? I know you gave me your name the other day. I wrote it down somewhere. I see you already have, oh yes, Nazia. Thank you very much indeed. Nazia. Nazia also found an answer there for age, and Nazia says it's 1. And I fully agree with you, Nazia, that's the correct answer. You may have to tell me how did you find it and the reasons why you did it like that. What did you do to get 1, in other words? I hope that everyone is also busy doing that. We will come to your answers, all of you. So Nazia, now that you have done A, I wanted you to tell me how did you calculate that, but of course you can carry on with the next, which is B and C. Let's carry on and then let's look at the answers. I'll just give you 30 seconds, like I said. Let me give you the last 30 seconds and then we can look at that. Okay, I see Amanda has done 2 already, and then she found whole number 6 and then 5/12. I can see that. And then Nazia again says that Nazia has added the numerators. Great, great, Nazia. You have added the numerators, and that is perfect. I'm talking about 1A, the reason being denominators are the same. So as always, when the denominators are the same, all that you need to do is just to add the numerators. So 2 plus 3 is 5, and then this will, the denominator will be 5. So 5/5 is the same as 1. Great, thank you, Nazia. I see, Amanda, you wrote 3 and 1. I'm not sure which one are you referring to. Are you referring to the second one? Right, Nazia as well has done C, and I see that you say it will be a whole number 4 and then 5/6. Perhaps if you can just tell me, it would be nice if you were just explaining it to all of us, if it's possible. All right, Amanda, thank you for noting the wrong answer there. If you can, at any time, you are welcome. You are free to raise a hand if you need to add anything. Right, the first one I've agreed. And then the second one, of course, I see, okay, Amanda, you got that one right as well, because you have got a 6, which is a whole number there, and then 5/12. And I fully agree with you. And the reason being, you have now converted your mixed fractions, I believe, into a fraction. And very important, how do you convert? There are some learners who may not know how do we convert a mixed number into a fraction. So I'm just going to zoom directly into that. So for the benefit of everyone, all that you need to do in B, all that you need there really is to multiply 3 by 3 here. I'm in B now. So excuse me, I mean B, you're multiplying 3 times 3 is 9, and then 9 plus 2 is 11. So you'll have 11 over 3. That is your improper fraction. So the second one here, you'll multiply 4 by 2 to get 8. And 8 plus 3 is 11. So you'll have 11 over 4. So remember that you now have two fractions, 11 over 3 and 11 over 4. So the denominators are not the same there. So when the denominators are not the same, all that you need to do is to check what is the common or the lowest common denominator. As you can see, the lowest common denominator will be 12. So 12 is the lowest common denominator because you simply multiply out. So to turn your numerators now, or to convert your fractions, 11 over 3, it means you are going to multiply by 4 in each case. 11 times 4 will be 44, 3 times 4 is 12. And then the other one, you'll just have to multiply the second one by 3, because 3 times 4 is 12. And then 11 times 3 is 33. I'm sure you understand what I mean. So it will be 44 over 12 plus 33 over 12 as well. So thereafter you add 44 and 33 there, and you'll get 77. So you'll see that 12 into 77, it goes 6 times. It goes into 72. And then the remainder will be 5 there. So hence whole number 6 and then 5 over 12. I'm glad that many of you got it. I see that Nazia has also multiplied the denominators to each other to get the lowest common denominator. Great. When you multiply the denominators, that's okay. You can get a common denominator. So you do the same with the next one, which is 4.5 plus 1 over 3. You multiply 2 by 4. If you multiply 2 by 4, you will get 8. And then 8 plus 1 is 9. So it means in this instance, your fraction will be 9 over 2 plus 1 over 3. So 2 and 3 are two different denominators. So you need to find the lowest common denominator, which will be 6 in this case, because if you multiply 2 by 3, you get 6. So I see, Amanda, you have got it right there. You've got 4 and then 5 over 6. I assume that when you multiplied everything, 9 by 3 gave you 27, and 2 by 3 is 6. And then 1 by 2 is 2, and then the other one is 6 as well. So if you multiply 9 by 3, you get 27. And then, of course, if you add 2 there, you'll get 29 there. So 29 divided by 6. So 6 into 29 goes how many times? I hope that you found it correct. I see you have got 4. So it goes 4 times. Yes, 4 times. Because remember that 6 times 4 is 24. So it's 4 times, and then the remainder will be 5. 29 minus 24 is 5. So Amanda is correct. You have whole number 4 and then 5 over 6. I see, I don't know if it's Nazia also got the correct answer there, 4 and then 5 over 6. Let me check who is that. Let me just quickly check. I think it's Nazia. Let's see. Oh, yes, it's Amanda, and then it's Nazia again. Yes, of course. Thank you very much both to Amanda and Nazia for taking the time and the trouble to do the calculations. So these were just additions of fractions. And the next step will be to look at I'm not going to do this addition again. I'm just going to, this can be your homework, but I'm just gonna go into subtraction. Let us now subtract the fractions. Remember, the same principle applies. Your denominators have to be the same. If you have a problem, please raise a hand and then let me attend to you. But the denominators have to be the same in order to successfully subtract a fraction from another fraction. The first one there, you've got 3 over 5 minus a half there. So 3 over 5 minus 1 over 2. So how are you going to find the answer there? Once again, very important, you need to ensure that your denominators are the same. I see that Nazia was the first to find the answer there. You've got 1 over 10, even Amanda. Huapili, thank you very much indeed. I see you also found 1 over 10. But can I just ask for just an explanation? If you can do it on the group chat. How did you find 10? Just to test your understanding there. For the benefit of all the learners, if you can just put it there, I'll appreciate. But remember that the most important thing when you add or subtract fractions, the denominator must be the same. If the denominators are not the same, you cannot subtract. So in other words, as I've said, you cannot say 3 minus 1, which is the numerator there, and get 2. And you cannot say 5 minus 2. Because if you do that, if you say 3 minus 1, you'll get 2. If you say 5 minus 2, you get 3. Then you'll say your answer is 2 over 3. That is correct. That is incorrect, sorry. That is wrong. That is not how you subtract fractions. The one way to subtract fractions, the denominators have to be the same. So the first thing is to find the lowest common denominator, which is 10. You can see that 5 can go into 10 without a remainder, and 2 can also go into 10, also without the remainder. And then once you have done that, then you know we are talking about the LCD. The perfect way to do this, you multiply both denominators there. You multiply 5 by 2. You also multiply 3 by 2. So your fraction will be 6 out of 10. In this case, you multiply 2 by 5, and then you multiply 1 by 5 as well. So you'll have 5 over 10. So the answer will be 6 over 10 minus 5 over 10. So 6 minus 5 is 1, and then the denominator is 10. So thank you to Huapeli, Amanda, and Nazia. Right, and then the second one, again, you can see we've just swapped the two fractions. We've got half minus 3 over 5. So basically, the lowest common denominator will still be the same. It will be 10, except that we have now swapped the fractions. Now, if you multiply out, again, you'll have 5 over 10 in the numerator, and then the second one you'll have 6 over 10. So 5 minus 6 is -1. So it means the next one you'll have -1 over 10. That will be the next answer there. -1 over 10 is your answer. And then, of course, the last one you do the same as well. You just find the lowest common denominator. I'm talking about 7 over 3 minus 2 over 5. And you can see that the lowest common denominator there is 15. Amanda already has an answer there, whole number 1, and then 1 over 15. Yes, I fully agree with you. The answer will be 1, whole number 1, and then 1 over 15. And how do you calculate that? By making sure that you find the lowest common denominator. So let me give you this homework now, just to add the two, in fact, the 3 fractions there, which are different from the ones that we had. and then we can carry on with our revision. This whole week we will be revising some of the work that we have already done, and then of course this will lead us to write our assessments next week. Thank you very much indeed. This lesson was brought to you by the STEM Digital School in partnership with the Sasol Foundation. Until we meet again tomorrow. Thank you. Savannah, I've noted your work as well, 29/15, that's correct, because that is the improper fraction. Thank you so much. Until we meet again tomorrow, have a nice day.